All right, so we're going to look at substation fundamentals. Just talk about some key aspects of substation operation. So today will be a lot of, hopefully, will be a lot of discussions. I sent you some figures in Schoology. I hope you have been able to access those. We'll see them in the presentation, but for reference, you have them with you. So you can go back and look at them and to gain a better understanding after we have gone through today's class. So let's get started. So let's just talk briefly about what a substation really is, and then we look at some of the other fundamental issues regarding it. So by way of definition, it's a part of the power system that acts as that bridge between generation and end users. Okay. Of course, you have the transmission system. Yes, we spoke about that before. We know about that. But here, we're dealing primarily with that link between the end users and the power system. And although I'm saying this, there are going to be some variations to it. But in essence, this is what the substation is used for. And I'm a little hesitant in giving this definition because you can classify a substation based on, on several things. You can look at it in terms of application, in terms of the service that it provides, or the voltages, or just by virtue of where it is located. So we can classify substations on that basis. However, generally speaking, it is that bridge between transferring electricity from generation or from your generation sources to your end users. And by end users here, we're not just speaking of basic consumers, all right? An end user can be an industry, right? A whole industrial complex. So I want us to always bear that in mind. So we're not just talking about your regular customers when we speak of end users. So as I said just now, we can classify substations based on the application. What is it being used for? Yes. We can classify it based on service. We can look at them or classify them based on the voltages that are present in the substation. Or we can look at it from the perspective of the location, design of your substation. Now, obviously there would be a limited list, but our purpose is not to go down and look at everything. So I'm going to just touch on a couple of these, look at some of the designations under application, under service. Of course, we mentioned those for the operating voltages and the locations or design. Yeah. And then I will touch on a few under application and service. All right. So that's how we are going to proceed. So let's start with application. What are some of the substations as listed under application? All right. So under application, we have your step up or step down substation, your primary or secondary substation. We have distributions if it's being used for distribution purposes. Yes. We can also have mobile substations, industrial substations. So these are some of the substations that would fall under application. All right? So you have step-up substation, step down. So the only purpose of these substations is to move the voltage from one level to another, and vice versa. So we bring it from one level to another, or up to another, or from one down to another. All right, so we are either bringing it higher or lower. Okay, and the voltage at which you'll be supplying your energy will have certain requirements. So in terms of the space in which you're operating, you may not be able to have a 138 kV line, for example. You know, I'm just throwing that out there. So you may not be able to have a 138, but you can have a 69. So to go in a particular direction, you know, you have the 138 coming into the substation, you bring it down to the 69 and move it on. Similarly, you may have the need for reducing the losses, given the distance over which the power would be supplied. And so you may require a 138 instead of your 69 installation. And so you'll need that step up. But let's discuss a couple of these. As I said, I will not go through all of them. I will just go through a few other relevant ones. So for your step up transfer substation, and what I'm showing you there on the right, I don't want you to think that it is what must obtain for a step-up substation, right? This isn't necessarily what a step-up substation must look like. But this is a picture of a step-up substation. So if you were to go, for example, down by Hunts Bay, heading east, if you look on the right, on the left rather, heading east, if you look on the left, across from the power station, you would see such a substation. All right. So if you look to the right, passing the power station, you'll see the step-up substation. All right. Of course, you have step-up transformers on the Hunts Bay facility. And I'm using Hunts Bay because, you know, it is one of the facilities that is quite visible, meaning generating facilities. Or better yet, for those going out to the airport, out by Rockford, all right, either coming down Mountain View Avenue, you'll see the substation just outside the power station. And so you have a step up there, but you also have some step down transformers, which provide power further out into Rockford. Flour mills, you have a dedicated feed up to flour mills, and then feeders going out to Rockford. So you do have a step down there, but you also have step up facilities that will bring it up to the transmission voltage. And I think Rockford ties back into Cane River. All right. All right. So your step up substations are directly linked to generating facilities. We know that here in Jamaica, our generation is coming at us at approximately 13.8 kilovolts. I'm trying, I think, well, you know, I have to be cautious with how I say this, but in terms of my own awareness of existing facilities, the highest generation voltage that I'm aware of is 24 kilovolts. If they have gone above that with increased technology for cooling, I am not aware, but for what I'm aware of, it's at 24 kilovolts. So that's what we are generating at maximum worldwide. But of course, we have voltages in terms of transmission up to 765 kilovolts. So obviously, you're going to need step up substations to facilitate that. All right. And we are fully aware that the higher the voltage transmission, it means that you are lowering your losses because you have a lower current flowing. And so your power losses, your real power losses, your P losses would be less. All right. For your step-down substations, they will receive the transmission voltage and provides input to the distribution substation. So what we're saying here is that it's not, I want to understand that this is not similar to the distribution substation. So these substations would possibly let, and because we are using such low transmission voltages here in Jamaica, it makes it a little difficult to help you to appreciate what we are talking about in terms of the need for a step-down substation. So in the UK, for example, the distribution substations are taking in 132 kilovolts, coming down from 400 kilovolts in terms of the major transmission lines. So at 132, you would take that down and supply it to a lower substation, which would be a distribution substation. And then the distribution substation would pass the voltage out on the streets, okay? Additionally, coming from these step-down substations, that 132, as the second point is highlighting here, may go directly to industrial facilities. All right. So in the case of a UTEC, I mean, we are coming from the old days, and Kingston is the only place, and I need to double check that. I know we have there's a voltage standardization in terms of distribution of 24 kilovolts. But at one point in time, we had some older transformers which were taking in voltages at lower values coming into the university. So we would have had some smaller substations here. So at present, we may be taking in 24 kilovolts. Because of our size, we have to provide our own substation. So what we are saying here is that for industrial facilities, they may take the straight 132 or and I'm talking about now in a jurisdiction such as the UK. They may take the 132 kilovolts, all right? In Jamaica, you know, a large facility such as, and I mentioned earlier that there's a dedicated feeder going into the flour mills. So they will take 24 kilovolts, all right? So from that step-down substation, you can then tap off those high voltages which are going into industrial facilities, and those facilities would then provide their own distribution of lower usable voltages, you know, get it down to their 110, their 220, etc., their 415, that sort of thing. All right. But coming from the utility itself, yes, you'll be getting 24. All right. I hope we understand that. So the step-down substation is not about distribution. It is providing a lower voltage for the distribution substations. So I can't think of any that we have here in Jamaica, but it would mean we are taking it from the 138, and from the 138, we then supply the substation with, say, 69. And from that 69, it goes down to 24, which is then fed onto the streets. I hope that is clear. All right. Any questions? All right, moving right along.
Sir?
Yes.
Yes, I was just asking about I was trying to get the different, but I think you already answered the question, to differentiate between the step-down substation versus the
distribution.
In Jamaica, that is.
You mean versus the distribution?
Yes, sir, because taking it from 69 to 24K, that is would be considered stepping down, a step down substation, correct? Or is it
In
a
in
distribution?
the strict sense of what we're talking about here, it would not be, because what we're saying, we're providing input to the distribution. So it's taking it from the high transmission to a lower, or if you want to call it a sub-transmission voltage. So because of the fact that our voltages are so low, which is what I said earlier, it is hard, it is really not I don't want to say the done thing, but in terms of the input to our distribution substations, their input are primarily 69 kV. So we take in 69 kV and bring it down to 24, and the 24 is what is now on the streets. But the 138 is what we transmit across country. You do have transmission along 69, but if we are moving from, say, out by Duane Park, Washington, rather, not Washington, Duane Park, out by 6 miles, yeah?
Yes, sir, that's what 130.
That's taking some 138 all the way into Trelawney and Manchester. Right? So those are going across country. If you look, you see the lines going over the hills. So that's taking some 138. But in terms of, if you want to call it local transmission, then that's at the 69 level. So when we talk about the step down will be taking it from the 138 to the 69. But the 69 is not a distribution voltage. That's the point I'm making.
Okay, sir, understood.
Distribution voltage is 24.
Yes, sir.
So the step down is taking it from the 138 to the 69. Then the 69 is the input to the distribution substation, which
yes,
then
sir, understood.
24. I hope that makes it a little clearer.
Yes, sir. Thank you very much.
All right. So on the distribution now, this is where we now take that 69. And I'm using 69 because of the fact that that is what we're using here on the island. All right. So that will now take the 69 and provide the 24 kilovolts, which goes onto the streets. All right. Now that 24 kilovolt on the streets, yes, is fed into the pole-mounted transformers. And those transformers are what you know get your 415, your 220, your 110. All right? Which is what us as customers would use locally. What do you call that? So, as I had mentioned UTEC earlier, all right? So I had mentioned UTEC earlier. UTEC would then receive a 24 kilovolt feed. And we will provide our own, we will be required to provide our own transformers, which then provide supply to the various facilities at, whatever voltages we require. All right. Okay. Again, what I am showing you here, it's not that this is what a distribution substation must look like, but this is a picture of a distribution substation. Right? And I have said it before, but we just want to make sure that people are clear on that. Okay. Continuing on application, we also can have what are known as mobile substations. So you have a mobile substation, and this is where you use in temporary installations, right? You can have a major construction going on. What you have access to, maybe the transmission system, but in order to complete that construction, even before you put in the substation to supply that area, you may need to have this mobile substation. Additionally, you may need to be rolling in this mobile substation if you have, I think here in Jamaica, what we do is just to roll in a transformer, really. So if you have, I recall there was a major fire out there in St. Anne recently. They just rolled in the transformer, switched from what was in the substation onto the mobile, so they could then deal with the damaged unit, and so the customers would not be out of power. Now, I know you haven't done it yet, and I say yet cautiously, but this is part of what we stress from a power system protection standpoint, that the objective of the supplier, right? The objective of the utility is to make the available to the customers electricity. That's the objective, right? And so whatever systems that need to be put in place to ensure reliability, ensure that power is always there, then that is what will be done. All right. Contrary to some of the lambast things that the current utility here in Jamaica gets, right? That's their real objective, to provide reliable electricity to its customers. And we'll discuss this briefly when we look at introduction to protection. All things being equal, we should start that next week. All right. Also, we have industrial substations. Okay. Now, again, this is not what it has to look like, but this is one. It would look no different from another substation, distribution substation. But the key here, when we talk about industrial substations, is that the utility, again, would provide a sub-transmission level voltage to the facility. So while
say that again,
they would supply a sub-transmission voltage to the facility. So in Jamaica, whilst our industries are, within the scheme of things, relatively small. So they would be supplying the full 24, but maybe, in other parts of the world, they may be supplying a 132 kV to the facility. That facility would then put in their own substation, which is what we are looking at here. They put in their own substation to distribute power within the facility. All right. Body clear enough? Okay.
Yes, sir. I have a question.
Sure.
Suppose it is that the industry that we are working with that is located in a residential area. Can the industrial substation be used to increase the voltage that goes in, or that's not a scenario that exists?
All right. That's a very good question. The reality is that industries are not supposed to be alongside residential areas. That's the reality. Now, one of and I say that because the considerations that the utility company will have to make for industrial / commercial facilities is completely different from the considerations for residential, right? Now, one of the things that you would have noted, well, no, let me not say that to you because it wasn't asked specifically, but that lab 2 that you did, one of the important learning lessons that you should have taken from it is that increased reactive power will obviously mean that there would be an increase or increased demand for reactive power would mean that there would be an increase in the apparent power. Everybody cool with that? Now, the reactive power would be, or the reactive power demand would be coming from use of motors and that sort of thing. Agree, Ms. Michael?
Yes, sir.
All right. Now, if I'm putting in a lot of motorized loads in my home, or should I say my facility, then the utility company will have to make the necessary provisions to supply that, which means that the transformers, which are rated in volt amperes, would have to be of the right capacity to supply. Now, when people, like we do in Jamaica, and a classic example is in the Eastwood Park, for those who are familiar with that area of Kingston. All right? Now, Eastwood Park was well, I say it was, but supposed to be a residential area. Still is a residential area. All right? Now, Eastwood Park is under siege from businesses. Now, the utility company, in trying to upgrade its facilities, may come to customers trying to find out what sort of load they are using, and they want to know what you have in your house. But our natural inclination as a society is to assume that the utility company's only goal is to see what's inside your house in order to increase your electricity bill. Is that a fair statement?
Yes, sir.
Exactly. Now, what they are actually doing, they have to know what the demand in a particular area is in order to efficiently size their equipment. So if people are in the residential areas carrying out commercial activities, it's going to put a strain on the utility company. So this is a very long response to your very short and your very short question, right? Which is that ideally industrial facilities are usually appropriately zoned and ought not to be mixed with residential or even commercial, because the considerations in terms of what the utility needs to do in supplying them are completely different.
Okay, sir. I understand better now.
All right, good. All right. Thanks for that question, Ms. Michael. All right. Now, from a service standpoint, we have converter stations, we have switching stations, and of course, we have collector stations. And I'm going to speed up a little now. You can refer to the recording for any further clarification. But please keep the questions coming, even though I'm going to speed up. For your converter stations, We don't have these in Jamaica. Yes. However, these facilities are used, you know, quite in a number of places in areas such as Europe. Let me explain quickly. A converter substation has equipment that can change frequencies, right? Now, for it to change frequencies, what it would need to do is to convert it from AC to DC and then from DC to AC, all right? We know that the fight between Maxwell and Edison was about AC and DC. All right. Did I send you guys that video?
So in Tesla, sir.
Tesla. What did I say?
Maxwell.
Sir? Maxwell. Tesla. Did I send you all that video? No?
Sir, it's not on the site, no, sir.
It was there. All right. Anyway, I'll put it up.
Yes,
but
sir.
between Tesla and Edison was about AC versus DC transmission or distribution, really. All right. So in order to move from before I talk about moving from, but in places in several countries in Europe, one of the biggest industry is that of electrical energy. So they sell electrical power. That's one of the big industrial commodity that is sold, right? France sells a lot of electricity because a lot of their electricity is produced using nuclear. And they will sell electricity to countries such as England, right? Now, France uses 60 hertz. England uses 50, which is why Jamaica is in this predicament, because we followed them, right? Most other countries use 60. And from your machines, you know that is, for use of a better word, a little more natural in terms of what we get from our generation. But that's not the debate right now. So these converter stations, what they are used for is to do just that. Move us from 50 to 60 hertz. Okay? Which is moving the AC to DC or DC to AC. All right? In order for the commercial exchange of electricity. You're switching substations. Yes? That's just it. We're switching. So you're moving supplies. Yeah? Switching our own lines. Biggest switching substation here on the island is Duane Park. Okay? One of our largest substations on the island, if not the largest. Okay? The other benefit of these substations is that it will provide some isolation under fault conditions. All right? But if you want to hear more about that, you have to come back in January. Okay? So our switching substations, without switching power lines, without necessarily altering the voltages. Right? They're almost seen as, if I use a better word, intermediary substations. Now, switching isn't the only thing that happens at Duane Park, and so let us be clear on that one. Okay. Also provides isolation, and when we look at some bus bar arrangements later, that may become a little clearer. And then lastly, in terms of service substations, we have what we refer to as collector substations, used in distribution power generation. Right? Now, as the power system evolved, or maybe I should say that first generation power systems were actually distributed. So you had little stations supplying, small communities. That's where we were. Call that first generation. And then second generation was that we shifted from those small generating facilities serving small communities to large power stations. Now that was really where Tesla came in. Yes, he's saying that let us do this using AC so we can put in large facilities and send it much further, right? And so that's where we moved. So we moved to having centralized generation, which was then distributed. And if I may say, third generation is that we then started to put in distributed generation. So we now brought back small generating facilities. So you have your little wind farms, you have your solar farms, you have your, well, hydro could be considered depending on the size of the hydro, right, as major facilities. But you get the point. We now have distributed generation, which is generation, small generation scattered across the network. All right. Distributed, or you may hear the term embedded generation. So they are now embedded into the system, which was looking from generation out. So it was generating facilities sending power out to consumers. So it was one-way traffic in terms of the electrical energy. With distributed energy or distributed generation, we now have power coming into the network from customers and from these other distributed facilities, distributed generation facilities. Now, for your collector station within your wind farms, and if you're, I may have sounded a little distracted earlier because I was looking for a photo I have of Wigton to show you just how the individual connections are made and then summed at the power station. But that's what the collector station is about. The power flow from multiple power sources is collected and then distributed to the grid by stepping it up to the transmission voltage. So if you go to Wigton, you would see them with a small substation on site. You would see the little collectors along the ground, all right, come into that substation, and then the substation, at least Wigton 1, let me speak to Wigton 1, it then sends it up to the Spur Tree substation, which is now coming into at the distribution, at the transmission level at 69 kV. All right. So we have spoken about application. So substations based on application. We have substations based on service. And we also have substations based on operating voltage. So for operating voltage, this one is nice and quick. For your high voltage substations, we're talking about, yes?
Quick question, sir. Sorry to bring you back to the convert of what those, sir, but my question is, as it relates to the frequency at which the voltage is produced, isn't it dictated by how many cycles per second of the generator itself, sir? And I'm speaking about the 60 cycles or the 50 cycles, depending upon the country, sir.
Yeah, but what I'm saying, remember for you too, I think we spoke about it not last week, the week before. We're talking about the conditions for you to have generation and being connected or interconnected with a system. Remember we spoke about that? Yes, no, Sir Blake?
I believe so, sir.
You believe so, all right. You haven't
Yes, sir.
reviewed it as yet. Anyway, we did. One of the things we said is that you had to add synchronization. It had to be synchronized. So if I am selling power into the, all right, let's say we are coming from France, which is 60 hertz. If I'm going to sell power to England, which is 50 hertz, there has to be synchronization. It has to be synchronized, yes? Do you agree with that?
Yeah.
Huh?
Yes, sir.
So what I'm saying, the converter station is where you would then convert it from 60 to 50. You on the way?
Yes, sir. I get that part, but the part when you were saying that you have to convert it to, oh, I think I misunderstand. I thought you said that you should convert it to DC, then to AC or something like that.
That's
So I was
exactly
saying,
what I said.
sir. So what I was thinking is, wouldn't by changing how many cycles per second, for example, it was at 60, by changing in the cycles per second to 50, wouldn't that be as simple as changing the frequency, or am I misunderstanding?
But the cycles per second is the frequency. What I'm saying, remember now, the power is produced at a certain frequency, which is based on the rotation of the generating unit and the number of poles, etc., etc. We agree on that?
Yes, sir.
All right. So that is what is being produced on the mainland, which is in France. So they are operating their system at 60 hertz. Agreed? Talk to me, no, man. Do you agree with that? Even if you're not sure.
Yes, sir. I agree, sir.
So they are at 60, but they are selling electricity to England, which operates their system at 50. Yes?
Yes, sir.
So remember now, in terms of the system itself, they are operating, the generators in England are operating at 50 hertz, just like it operates here in Jamaica. But in order for them to purchase power from overseas, so they're purchasing electricity just like they're purchasing rice. For them to purchase electricity and use it in their system, which is operating at 50, we need to convert the 60 to 50.
Yes, correct.
All right. So let us forget about the power system. Think of a solar PV system. Yes. When you get what the output that you get from your panels, I'm going to be troublesome now. The output you get from your panels, what is the frequency?
Sir, I don't know, sir.
Come on.
Zero, sir.
Zero. Why?
Because you don't have anything rotating or.
It's DC. Yes. There's nothing, no rotating part. It's DC. So you're getting DC from your panels. But we said it last 2 classes ago, right? That what you're going to then do to get it to AC is to do what? Come on, man, and talk to me, man. We only have one.
Convert it, sir.
You need an inverter. All right? So you're going to need your inverter, and your inverter is going to produce that AC at 50 or 60 hertz. Because all of the equipment in your house, no AC them run by.
Okay, sir. So I think I understand, sir. Because what I was saying that maybe they turn down the speed of the generator to match with the 50 hertz.
No. They convert it to DC and then from DC to AC.
Yes, sir. I get it now, sir.
All right. So just like from your solar PV, which was DC, coming from the panels on the roof. Yes? When it comes into your inverter, that is then converted or inverted, if you use a better word, inverted and you get the DC, the AC being produced at 50 or 60 hertz. All right?
Yes, sir. Thank you, sir.
Not a problem. That's what I'm here for. So quickly, coming back to the voltages. We call a high voltage substation between 11 and 66 kilovolts. So our substations are at least high voltage because all of them has a minimum 24 kilovolts inside, right? So that is why you will see the sign, high voltage. They tell you up front. So it's a high voltage substation. We're talking about extra high voltage, then we're talking about the 132 up to 400, all right? We run 138 as our highest voltage here in Jamaica. We don't need nothing bigger than that. In places like the UK, they go up to 400 kilovolts. In parts of the US, they go up to 765K. So those would be ultra high voltage substations. And of course, you have DC, right? So you still have DC transmission. So we call it high voltage DC. So HVDC, right? High voltage DC transmission voltage.
Excuse me, sir.
Yes.
That would be used in like is it telecommunication that mostly use that kind?
No, man, in some areas, they transmit in DC. It has some benefits. They don't come directly to mind, no? But I will look at it and get back to you. But in some instances, there are some benefits that, as I said, just don't come to mind at present.
Okay, no problem, sir.
From your HVDC. All right. And then lastly, in terms of specification, we talk about location. All right. And I'm going to pause here because I need to just run out, get something signed and come back. For location, I just speak quickly to the two that would be of interest to us. For your indoor, when we talk about an indoor substation, and I hope you understand that there can be some overlap based on what we have discussed so far. So your indoor substation, yes, can also be a distribution substation. You with me? So we classify them based on, operation. So for your indoor, on the roof, our closed compartment used for voltages up to 32 kV. An example of this would be your Hope substation. There's an indoor component to it. The distribution side of the substation is housed in a room on property. And for your outdoor, open air, and it's for voltages 66 and above. So I will simply tempt you by saying that if you're interested in going to visit these things, then I'll have to see you in January. All right. I'm going to pause here for a few. I'll be right back.